Hi friends, welcome back. Today we are going to solve Leetcode problem 735 asteroid collision. This problem was asked in coding interview question by Lyft. So before we start looking into the problem statement and some examples, I just want to mention that my channel is dedicated to help people who are preparing for coding interviews and Java interviews. And on my channel, you will find more than 200 solved coding interview questions from big tech companies like Amazon, Facebook, Google, Apple, and many other big companies, and those covers different important varieties from coding interview perspective, such as dynamic programming, graph related problems, binary search tree related problems, binary search related coding interview questions, as well as string and linked list related interview coding questions, and BFS, DFS, matrix related problems, and optimization problems, priority queue related problems. So if you are preparing for coding interviews or Java interviews, then please subscribe to this channel. This channel can definitely be of help in your Java interview preparation. So please subscribe it. So now let's go and we'll just discuss the asteroid collision problem, which is the interview question asked by Lyft. So we are given an array asteroids of integers representing asteroids in a row. So for each asteroid, the absolute value represents its size and sign represents its direction. So positive means that it's going to right and negative means that it's going to left. Each asteroid moves at the same speed. Find out the state of the asteroids after all collisions. If two asteroids meet, the smaller one will explode. If both are same size, both will explode. Two asteroids moving in same direction will never meet. So they have given us these four different examples. So we will discuss all these examples, but for example, in this second example, right, the this asteroid, first asteroid 8, it is going on to right direction, and this -8 means it is going on to the left direction. So both will meet each other and both will explode, right? Because both have same weight basically, right? So both will explode. So the result will be empty, right? Nothing will exist after the explosion or collision, right? So let's just take all these examples over here. So we can go through. First we have to understand this, what the problem is, and then we will propose the solution and look into the implementation, right? So these are the three remaining examples that are given to us. So let's just so in this example, one important thing is to understand that each asteroids are have direction, right? So for example, let's just put a image here how the asteroid will look like, for example, right? So let's say this one is the asteroid which has a weight 5, right? It has a weight 5. This one is a bigger asteroid which has a weight 10, right? And this one is a small like this one has a weight again it has a weight 5. So now the important thing is this asteroid in going in right direction, this is also going in right direction, and this one is coming from left direction, right, the asteroids. So now the first thing is you will see that this 10 and 5, they will collide with each other, right? They will have a collision, and since 5 is smaller than 10, 5 will disappear after the collision, right? So 5 will disappear after the collision, and 10 and 5 will keep going on the right direction, right? So that's why we have to output 5 and 10. So 5 and 10 will be the remaining asteroids, correct? So with the symbols also, right? So here I did not put a symbol because I just put a direction, right? Left means it's going in left, which means -5, right? So this is an example 1. Let's go through this example 2. So in example 2, let's just draw just a sample image here. So let's say 10 is one asteroid here, right? So this is a big asteroid, let's say, and then there is a smaller asteroid, let's say 2 asteroid. Its weight is 2, right? So this one is a smaller asteroid, and both of these asteroids are going on the right side, right, in the galaxy, and this one in a 5. So 5 is little bigger, but it is negative. So negative, what it means is it is coming from left to right, right? It is going in this direction. So now first collision will occur between 2 and 5, right? This one will collide with each other, right? 2 and 5. So now 2 is smaller, right? So 2 will be disappeared, right? After the collision, because smaller disappears, and after that 5 will keep going and it will collide with 10, right? After that, and since 5 is smaller in this case than 10, then 5 will disappear, right? After the collision with 10. So 10 will keep going on right direction. So only 10 will remain, right? After the collision. So here, as you can see, the answer is 10 here, right? So let's go with this another test case. They have given us this one example. So let's say -2 -1. So let's just draw one more image here. So this is 2, this is 1, right? And then 1 and 2, right? 1 and 2. So 1 and 2. So now the first two are going on left side, right? So this will go left side. This is also going on left side, and the last two are going on the right side, right? Right side. So as you can see from this image, no collision will occur in these asteroids, right? Because these two are going left side, so they will never collide with anything. And these two are going on the right side, right? They will never collide with anything. So we have to just output, the output will will look same as input, right? -2 -1, 1 and 2, right? As you can see it here. So this is what the basically the problem is. So we have to understand here that all the asteroid has a direction, right? So which data structure we can use to simulate that this collisions, right? Because for example 5 is going here on the left side, right? This one is going on left side, this one is going on right side. So 5 has to first collide with 10, right? Before it can collide with anything else. For example, in this example, right, 5 has to collide with 2 first, and then it will collide with 10, right? So in this case we are going to use stack, right? In this the data structure we will use is stack, for example, right? So I'll just simply draw a sample and then we'll go to another whiteboard. So in this case, why the stack can help us is if we are going through this array, right, of asteroids, I can put that in the stack, right? I put 10 here, then I put 2 here. So whenever I get another asteroid with another direction and there is a collision, right, then we can take out from the top, right? And then we can simulate the collision between 2 and 5, right? And then 2 will be gone basically, because 2 is smaller, so we will remove that from stack, right? And then 2 is out of the stack now. Then 5 will collide with 10. We will simulate that. We will check if there are any other collisions possible. We will simulate collisions. So 5 will collide with 10. So now 10 is bigger than 5, so 5 will disappear in this case, and then 10 will remain in the stack. So we will just take all the elements pop out from the stack, right? And then we will put our result array, right, like this. So this is the approach we will take. So now let's go with some examples before we can actually discuss the code, right? So let's just say we are looking into this direction from array, right? So we will use stack. So let's just first go ahead and create one sample stack here, right? So whenever we see any positive first element, stack is empty, so we can just put that element into the stack, right? Now the next is 10, right? So since 10 and 5 are going in same direction, which means that we have to also put the 10 on stack, right? Because they should not, there cannot be any collision, they are going in same direction. So -5, when -5 will come here, the next one, then it is going in opposite direction. So we have to simulate the collision between 10 and -5, right? And since 10 is bigger than -5, the -5 will disappear. So we will not do anything, right? Means the stack will look like this after the collision. 10 will remain there, and we are done with all the stack, all the array of asteroids. So after that, we will take out these elements from stack and we will put that into the array, right? So in the from ending to start, so end I will put 10 first, 10 will be popped out, then 5 will be popped out, and it will be put on the before 10, right? So as you can see, this is how we will form our result array. So let's look into this another example here. So I'll just take this out so I can reuse the space again. So uh, just a second, let me just copy this. I think I cannot do the control Y. Yeah, I think let me just copy that example in a second, or I can just write it, it's okay. So 10, 2 and minus 5, right? So we have, let's say, 10, 2 and minus 5, right? So 10 and 2 are going onto the right side. So let's just say that we have a stack here. So 10 we will put into stack, right? First element we don't have to check, it's always goes on stack. 2 we will again put onto stack, because it is, they both are going in same direction, right? So whenever we are putting into stack, we will just use kind of, we can multiply these two things, right? So whenever multiplication comes as positive, that means that we can put that into stack, right? Because if it is negative, then we cannot put that into stack, but this one is positive, right? 10 into 2 is 20, so we will put that into stack. Now after that, for minus 5 will come, right? So minus 5 will come, so we will always pick the stack, right? So now we can simulate that the collision will occur here in the asteroids. So 2 will be, so we can simulate here that the collision will occur, right, between uh, 2 and 5, right? So in that case, we 2 is smaller than 5, so we have to pop out the 2, right? So 2 will be out of the stack. Now we will check, if there are any other asteroids, we can make the collision, right, between 5 and 10. So since 10 is bigger than 5, then 5 will disappear here, right? Then only 10 will remain basically. So 10 will remain, and we have to take it out of the stack and we have to put it back, right, into our result array, right? So that is our approach. So 10 will be the answer in this case. As you can see, 10 is the answer here, right? So this is our approach, and let's just take this another last example quickly. So minus 2, minus 1, 1 and 2, right? So let me just reuse this space again. So minus 2, minus 1, 1 and 2. So in this case, we will have to put this again now into the stack, right? So minus 2 will come first, so we will put minus 2, right? Then minus 1 will come, so we will put minus 1, right, into the stack, because they are going into same direction. And then 1 will come, right? So 1 will come. So in this case, it is minus 1, right? 1 and minus 1, 1 into minus 1 we will do, so the multiplication will come as minus 1, which is less than 0, right? So in this case, we are going to put that 1 into the stack, right, because they are going in opposite direction, so we cannot make any collision, right? So we have to add that into the stack basically. And then last remaining element also, 2 into 1 also is positive amount, 2 into 1 is 2, which is greater than 0, right? In this case also we have to put it into the stack, right, because we cannot make any collisions between 1 and 2, because they both are going into same direction, right? So we will put that into the stack, right, in this case. So as you can see, there cannot be any collisions because of the direction, so we have to put that into the stack, all the elements, because we cannot do any collisions, as I explained, right, as you see here. So because 2 and 1 are going to left side here, right, and 1 and 2 is going to right side, so there cannot be any collisions. So now we will have to take out all the elements from stack. one by one, and we have to put those elements into our result array. So we will, when we are putting it into our result array, we will start from the end basically, right? So we will put like 1, then 2, then -1, and then -2, right? -2. So -2, -1, 1 and 2. So it is same as the input array, as you can see, -2, -1, 1 and 2. So this is the way we are going to use a stack, and we are going to solve this asteroid collision problems. So let's go quickly over the implementation in Java. So let me just open this another window. So as you can see, this is the implementation using the stack, right? So first thing is we have been given this asteroid collision array, right? So let's say we will just check this array. If it is 0, then we'll just return null, right? Because in that case we don't have anything to check, right? This is the basic check we are doing first, and after that I just created a stack of integers, and I am iterating through the array, right, one by one element. And here first we are checking if the stack is empty, then we will always put the first element, right, into the stack. And then we will always check for the next subsequent elements, we will peek the stack, right? So we will always go to the top of the stack, and we will multiply with the current element. And if it is greater than 0, then it means that they are going in same direction, so we will push that element into the stack, right? So as I explained you here, so -1, so when we see -1, so -1 into -2 is equal to 2, right, which is positive, right? So they are going in same direction, so we will push that into the stack. So after that, if these conditions are not true, right, then we will check the top of the stack, right? If it is less than 0, if let's say if something like minus is there, right, in this case -2 is there, for example, when in the beginning the stack is empty, so we will put -2 here, right? And then when -1 comes, so in this case we will check this one, right? Like we will always pick the stack. If it is less than 0, then we will have to push that into the stack, right? Because the multiplication will come as positive, right? So else we will simulate here that we are this one is basically this while loop is to simulate. I'll just write down simulate the asteroids collision, right? Collision. So we will go through each and every element of the stack until stack is becoming empty, and if the top of the stack element into the current element, if it is less than 0, right? For example, let's take the example of this one, right, 5 and 10. So let's say we have 5 here, first example, right, 10 here, and then -5 will come, right? So -5 into 10, so this is a negative amount, right, -50. So in this case, right, so in this case we here, right, so it's minus less than 0, so we will pick the, like we will do the absolute of the first like top element of the stack and the current element, right? If the top element is smaller, right, in that case, which means that we have to pop it out, right? Because the other coming asteroid is bigger than the one that we have on the stack, on the top of the stack, right? So we have to remove it basically, right, in that case. So that's what we are simulating here. You got it, right? So for example, let's say this, if this one is -15, right, let's say this one is -15 instead of 5, so -15, then in that case we will take 10 out, right, because 10 is smaller than 15 basically, right? So that's what we are simulating here. And if the stack is empty, or the first element of the top is greater than 0, if that happens, if the first top element if is great, like into the current element, like the product, if it is more than 0, which is positive product, then we have to push it, right? We will have to push it basically. For example, so let's say we have a stack we have stack like this 5 10, right? And if something comes, let's say 20 comes, right? So 20 we have to push it into the stack because the product is 200, right? It's positive, and since they will be going in same direction, right? So we have to push it basically in that direction, in that stack. So this is what we are doing here. Otherwise we will again do the absolute value of the current and the stack, top of the stack, right? If both have same weight, right? So for example, let's say 5 and 10 here, right? Let me just clear some space here so I can write. I think it's just, yeah. So let's say we have 5 and 10 onto our stack, 5 and take 10 onto our stack, and if we have minus 10, which is a asteroid coming in reverse opposite direction, so this both will collide and 10 will means both will become non-existent, right? Means both will disappear basically. So in this case we have to take this 10 out basically, right? Because they are both matching in the weight basically, right? So that's what we are simulating here. That's why we have to take absolute value, right, of math, and absolute value of the other one, right, the coming one. So we are popping out of the stack in that case. Otherwise, if the top value, if it is more than the this value, right? If the top value is more, for example, we have 510, right? 510, and asteroid which is coming from other direction, if it has a minus 5 weight, let's say, right? So 10 is bigger than 5, right? So in that case, uh, let's see, right? So 10 is bigger than 5, so in that case we will break basically, right? So we are breaking from the while loop because there is no collisions which is possible in that case, right? Because 10 is already bigger, so this will disappear, right? In that case, so there is no collision possible, so there won't be any change into the stack values. So that's what we are simulating. So at the end we will just go through the all the stack values in the opposite direction, right? As I said, opposite, so we are going from reverse direction, so we can form our array result, right? So this is all about the solution for the asteroid collision problem that was asked by Lyft. So we can solve this problem with the help of stack and with this help of logic, right? So stack is very helpful to solve this problem because we need to understand the order right here, because 10 will first collide with 5, right? And then 5, let's say, or for example 2 will first collide with 5, right? And 2 will disappear, then 5 will then collide with 10. So to simulate this kind of behavior we need a stack, right? Because stack holds uh, so stack is uh, last in first out, right? LIFO basically, right? Last in first out, right? So whatever we insert last is comes out first basically, right? So this is the way we can solve asteroid collision problem. um, if you haven't already checked my playlist on my channel, there is a separate playlist called as Leetcode and Leetcode solutions, and that playlist has over 200 solved examples. Those are coding problems taken from different interviews, and those were asked by big tech companies like Amazon, Apple, Google, Facebook, Microsoft, Yahoo, and many others. And those were handpicked problems to make sure that it covers all the important varieties such as dynamic programming, graph problems, binary search tree problems, binary search related coding interview questions, as well as BFS, DFS, matrix related questions, linked list, and string related coding interview questions as well. If you are simply preparing for Java telephonic interview or screening interview, there is another playlist called as Java interview, and that is focused on frequently asked telephonic questions by big tech companies, and how to answer those questions is explained along with Java design patterns and architecture related questions as well. So please go through it. If you like this video, if you find the explanation with the examples helpful to understand the problem and the solution, then please hit like and subscribe it. Your subscription is really important to the channel because that is the way the videos can reach to more people who need help understanding coding questions and coding problems and how to solve those problems. So they can also prepare for their interviews, and they can also understand how to approach the different variety of problems. So please subscribe to the channel, and if you find this video helpful, please give a like and share this video with your friends and colleagues, and thanks for watching the video.